In my opinion, Alibaba's recently open-sourced Tongyi Wanxiang, Wan2.1 can be considered the current leader in the video generation model field. The output quality is outstanding, fully comparable to closed-source commercial models. A few months ago, who would have thought that consumer-grade GPUs could generate videos of this quality? The only downside might be that the generation speed is just a tiny bit slow. Moreover, it also supports image-to-video generation, making it even more versatile. For example, you can use large language models like DeepSeek to write storyboards, let Flux generate images, and then hand them over to Wan to convert them into videos, effortlessly creating children's picture book stories. This open-source release includes 4 models in total. Among the text-to-video models, there's a 1.3B parameter entry-level version, which can run even on low VRAM GPUs, and a more advanced 14B parameter version, which offers better results but is significantly slower. As for the 2 image-to-video models, both also have 14B parameters, but they target different output resolutions, 480p and 720p. Each model comes in various formats, including BF16, FP16, FP8, and GGUF. Later, I'll compare them and discuss how to choose the most suitable version. Without further ado, let's see how to use these models in ComfyUI. After opening ComfyUI, the first thing to do is to check the ComfyUI version and update it if needed. Although Wan2.1 is supported from version 0.3.16 onwards, later versions, 17, 18, 25, and 26, have continued to optimize its performance and fix various bugs. Today, I'll demonstrate using the native workflow, which involves 2 plugins, KJNodes and Video Helper. The former is responsible for acceleration, T-cache, and quality enhancement, enhance a video, while the latter is used for video composition. Both can be updated via the manager. Wan2.1 supports both text-to-video and image-to-video generation. In my opinion, image-to-video is far more practical, as it defines a clear starting point for the video, significantly reducing randomness in the final output. You can use an image generated by another, more specialized model or even a real photograph. Before running the video generation, you can also repaint or fine-tune the image, avoiding Wan2.1's inherent limitations. By the way, its rendering of hands isn't great. So let's start with image-to-video generation. Load the workflow provided by ComfyUI's official repository. For models, I prefer the 480p FP16 version, with UMP5_XXL_FP8 for clip, while clip_vision_H and Wan_2.1_V handle image processing. Now, upload an image of a girl. Quick side note, Wan2.1 is exceptionally good at bringing portraits to life. I want her to wave. How should I write the prompt? The official documentation provides recommended prompts for both text-to-video and image-to-video generation, defaulting to Qwen+, text, and Qwen Max, image. However, you can also use DeepSeek or ChatGPT if you prefer. Here's my final prompt. About video resolution. I need to emphasize one point here. The 2 image-to-video models released this time, 480p and 720p, both have 14B parameters and the same file size. They are optimized for different output resolutions, so don't try to use the 720p model to generate 480p videos, it won't improve the quality. There are many different aspect ratios for 480p and 720p, but the official introduction of the model provides specific resolutions. I guess this might be the specification of the training dataset, which theoretically should yield better results. So I added a resize node to adjust the image to 480 by 832, but I also tried 512 by 768, and the difference was not significant. The frame count is set to 81. And I need to fix the seed to facilitate subsequent comparisons. Finally, I replace the output with video combined to save an MP4 video at 16 fps. Click Run, and we need to be patient for a while. The first run requires loading the model, which takes quite some time. The sampling phase of Wan2.1 is also not fast, and decoding is not instantaneous either. I'll speed it up. Pay attention to the time displayed for these two nodes. Sampling, 647.15 seconds. Decoding, 5.144 seconds. Opening the preview. After waiting for so long, the result is quite good. The girl is smiling with her eyes squinted, looking extremely cute. However, the sampling speed is indeed a bit slow. We can't wait 10 minutes every time, so let's try to speed it up using the Wan Video Tcache native node from the KJ Nodes plugin. Tcache is a timestep embedding aware cache strategy. We need to first analyze the model, test the output data at each timestep, and calculate the L1 distance between different timesteps to assess the degree of change in the model output between consecutive timesteps. Then, we determine the optimal threshold and time step range, start and end. During inference, Tcache reuses cached data to skip certain computation steps, achieving acceleration. Initially, GGUF calculated the values manually, but later, Wan's official team provided a reference. I am using the 480p I2V model, and its default coefficients match this model. The recommended value range is 0.13 to 0.26. So I'll set it to 0.2, the larger the value, the greater the acceleration effect. The start time should avoid the first two steps, or the motion effect will be significantly worse. I'll set it from 0.1 to 1. No other changes, click Run. It's a bit faster now, but I'll speed it up further. The final output is hard to distinguish from the previous version. Checking the backend logs, decoding, 5.192s, almost no difference. Sampling, 459.18s, previously 647s, saving nearly 200 seconds. The logs indicate that Tcache skipped 6 out of 20 steps. Since the video quality remains nearly the same while the sampling speed improves significantly, I will enable Tcache by default from now on. Enhance a Video is a video enhancement solution that incurs almost no additional computational cost. We previously introduced it in ComfyUI Video. Now, let's add it to this workflow. Add the Wan Video Enhance a Video native node. It has only one parameter, strength, ranging from 0 to 10. KJ Node's default value is 0.2, while Enhance a Video's official default is 4. There is no universal best value, so feel free to adjust. I will set it to 2. Click Run and speed up the process. The sampling time, for 51.521s, has hardly changed. Comparing it with the previous video, it might be slightly better. For those with lower VRAM, GGUF models are an option. However, you need to update the ComfyUI GGUF plugin, or you will encounter errors, even though the author only changed one line. For GGUF models, Q6_K offers the best balance. It is relatively large but should run fine on 12 GB VRAM. Models below Q4_K_S have very poor quality. Using GGUF models. 1. Place the model in the diffusion_modules directory. 2. Replace the model loading node with unetloader, GGUF. In this workflow, the Q6_K model produces a final output with excellent quality. Sampling time, for 34.488s, slightly faster than FP16. FP8 is also an option, but I personally feel GGUF performs better. Additionally, Q6_K is slightly smaller in file size than FP8. If you have a 4090 or a better GPU, 16 GB VRAM is barely enough. You can use the 720p model to generate higher resolution videos. For best quality, I still recommend using FP16. Here is a 720 by 1280 HD video I generated. Increased resolution. Sampling time, 1597.765 seconds. When Wan2.1 was released this time, the official workflow included negative prompts in Chinese. This led to a speculation within the community, would using Chinese prompts yield better results? Many people even installed plugins to translate English prompts into Chinese because of this. Let's give it a try. I replaced the prompts with their equivalent meanings in Chinese and ran the process again. The result is out. This time, the motion is slightly shorter than with English. The girl's hand was just about to wave when the video ended. However, the video quality itself remains intact, likely due to the seed. Personally, I don't think there is any difference in effectiveness between English and Chinese prompts. Feel free to use whichever language you're comfortable with, no need to struggle with translation plugins. Why does one understand Chinese? That's thanks to the UMP5XXL text encoder, which claims to support 107 different languages. I even tested using emoji as positive prompts in text-to-video generation. I only input 2 emojis, a sheep and the sun, and the output was correct. It really understands. To continue comparing different parameters in the following tests, I'll switch back to the previous prompts. Step count has always been a key parameter of interest. The reference code provided by the official team uses the following default values: 50 steps for text to video, 40 steps for image to video. Just now, I used 20 steps, so let's try 40 steps this time. After waiting a bit, let's compare the results. The overall motion remains nearly the same, with no major differences in movement, only in details. The blinking effect appears more natural, and the hand shape is more complete. More steps do indeed yield better results, but at the same time, sampling time also increased to 649.763 seconds. You can start with fewer steps to quickly preview results, then increase the step count for the best outputs once you're satisfied. There are many sampling methods. Wan2.1 officially recommends only UNIPK, default, and DPMPP, but in actual testing, Euler_ancestral, and gradient_estimation also work. I'll try running DPMPP_2M/SGM_uniform to show you the results. The videos do have some differences, but it's hard to say which is better. Just choose based on your preference. Personally, I usually stick with the default. For CFG, it's best to keep it at 6, as setting it too low can easily break the video. The frame count should be a multiple of 4+1, for n+1, but in my opinion, the default 81 frames work best. Different frame counts will lead to different motions, so I won't demonstrate all of them. Instead, I'll directly show you the results of 33 frames and 121 frames with the same parameters. The more frames you use, the higher the VRAM consumption. With my settings, a 4090 struggles to handle 161 frames, often leading to OOM errors and even visual artifacts. Like previous video generation models, one also supports LoRa. And not just for character LoRa. You've probably seen that stretch effect that went viral with Pika. Well, Remade trained a LoRa for Wan. Let's download and test it. Place the file in the LoRa's directory, add a LoRa loader model only node to load the model. And adjust the prompts accordingly. We'll keep the first frame image unchanged and replace the rodent character with a girl, following the author's formatting. Reset the sampling method to default. Click Run. And sure enough, the effect appears as expected. There are also different effects from the same series. If you're interested, feel free to download and try them out. Additionally, I've created a workflow with an extended segment, making it easier for everyone to expand their videos. The first half is the image-to-video process we just used. The middle part extracts the last frame of the previous output and uses new prompts to generate a new video segment, achieving a staged control similar to prompt travel. Finally, both segments are merged into a longer video. Click Run to check the results. The transition is seamless, almost like generating a single long video. Theoretically, by modifying this workflow, we can keep extending the video infinitely. If you're interested, give it a try. Here's the translated text. By now, everyone should be quite familiar with Wan2.1's image-to-video feature. So let's take a look at the cooking sequence of the little lamb at the beginning. First, we need to find a large language model, such as DeepSeek, to act as a director and generate a storyboard for us based on this theme. The output should follow a 4-panel animation format to maintain consistency without using LoRa. Next, we open the Flux text-to-image workflow and use the generated prompt to create images. It might take multiple tries to get a satisfactory result. Then, we split the image into 4 panels using a tool or plugin, obtaining 4 initial frames. Each frame is processed in Wan's image-to-video workflow to generate 4 short clips. Once combined, we have a complete short story. Here, I'm demonstrating this with a children's illustration style using LoRa. But if you prefer a realistic style, the results will be even better. Get creative and experiment. That concludes the introduction to the image-to-video feature. The results are excellent, though I hope they add first and last frame control in the future. Now, let's explore text-to-video. I'm loading a pre-prepared workflow that includes not only the basic text-to-video process but also Tcache and enhance a video. First, I'll select the 1.3B FP16 model, and later, we'll compare it with the larger 14B model. The clip and VAE settings remain the same as in the image-to-video workflow. For the Tcache node, make sure to select the corresponding 1.3B model under coefficients, set the ref_L1_thresh to between 0.05 and 0.08, and keep the start time between 0.1 and 1. The weight setting in Enhance a Video can be adjusted to personal preference. I like setting it to 2. For the prompt, I'll use the official large language model generated instruction. Since the 1.3B model only supports 480p resolution, I'll keep the size at 480 by 832. If you want a higher resolution, like 720 by 1280, you'll need to either upscale or switch to the 14B model. Frame count follows the same 4n+1 rule, so I'll keep it at 81. I'll also fix the seed for easier comparison later and set the sampling method to dpmpp_2m, which I find slightly better for text-to-video than uni_pc. For text-to-video, I'll use a slightly higher step count, let's go with 30, clicking run. After 91.234 seconds of sampling, the result is ready. Compared to many video generation models, this output is already quite good, but since the image-to-video quality was so impressive, this one feels a bit lacking. The 1.3B model is much faster than the 14B model. Now, let's keep everything the same but increase the step count to the official recommendation of 50 to see if the video quality improves. This time, sampling took 135.657 seconds, over 2 minutes. The video now looks noticeably different, so let's pick a few frames to compare. The quality has indeed improved. Since the 14B model also supports this resolution, let's see how it performs. After adjusting the model and Tcache parameters, and reverting the step count to 30, I hit run. The 14B model is significantly slower. It took over 9 minutes, 549 seconds, to generate the result. Now, was it worth the wait? In my opinion, the advantage of the 14B model over the 1.3B model lies in its understanding of video, which translates to better motion continuity and object consistency. However, if you want higher detail and quality, you'll need to increase the step count regardless of the model used. From a cost-effectiveness perspective, I generally use the 1.3B model with tile LoRa upscaling. Let me share a workflow for that. On the left is a standard text-to-video process with Tcache and enhance a video. But let's focus on the upscaling part on the right, which uses a tile control LoRa released by SpaceEpsil for the 1.3B text-to-video model. First, the image is upscaled 1.5x, then blurred slightly per LoRa's requirements, which seems counterintuitive. Because of this, this workflow isn't suitable for enhancing image-to-video outputs, as it can actually reduce detail in already high-quality videos. Once LoRa is applied, the blurred video is used as a control signal, and we run a 30-step sampling to generate a new video. Clicking Run, and waiting patiently. If you use this workflow, all you usually need to do is tweak the prompt to match your intent. The results are in. The first sampling took 91 seconds, and the second took 342 seconds, totaling around 6 minutes. The original video was 480 by 832, and after upscaling, it became 720 by 1248. Let's compare the two in ComfyUI, picking a few frames for a side-by-side look. The difference is obvious. Hair and earrings appear more refined after upscaling. That wraps up this video demonstration. As for why I didn't use CGI's wrapper plugin, it's mainly because native ComfyUI is still more convenient for text-to-video and image-to-video tasks. I might cover advanced wrapper features like video-to-image editing, Flow Edit, in the future. Summary: Wan2.1, especially its image-to-video model, is currently the highest quality open-source model. It's incredible that an open-source model can generate over 5 seconds of 720p video. Use FP16 models if you have high VRAM, otherwise, opt for FP8 or GGUF-Q6_K models for equally good results. The only downside is that it's slow, so I recommend queuing up tasks overnight and checking the results in the morning. It's definitely worth trying. That's it for today's video. The model, plugins, workflows, and system instructions are all linked in the description. Feel free to check them out. See you next time.